Thanks very much for inviting me, especially inviting me back. So I do appreciate that quite a bit. And this is a little bit of an odd topic. It's actually something that something I've been thinking about for a long time. Um, and we'll get into the motivation for this in a moment here. But before we start, let me just do a quick time check. How much time do we have for the talk?
About an hour is
Oh, no problem.
okay.
Not a problem. Okay, very good. So my name is George Ziforpoulos, KJ6VU. I'm a refugee from California. I moved from California up to Oregon about 2 years ago. So I used to live in the Bay Area for those 40 years in San Jose. So it's great to be able to have an opportunity to chat with you guys at Park. So thank you again for having me. A little bit of background about myself before we dive in here. So I've been licensed for a while, since '72. Most of my ham radio activity, kind of all over the map. I do a lot of repeater building and a lot of portable station building and that sort of stuff. I have a podcast called the Ham Radio Workbench, which some of you might have heard about. And also, we talked about antennas the last time, HF portable antennas. I make some antennas called Pactenna. And I also make a line of repeater control systems, which kind of dovetails into tonight's conversation. So I'll explain a bit more about that. If you've never heard of the podcast and you're looking for something to put you to sleep at night, this would be a good place to start. So if you can go to the web or to any podcast player, you can find our show. We talk about hands-on technical topics, mostly around building stuff, whether it's building stuff with a microcontroller or rejuvenating an old tube radio or picking your favorite voltmeter. We have all kinds of episodes on those topics. So would love for you to check it out. We have over 200 shows that you could download and listen to. And as I mentioned, I make antennas and repeater control systems. I've officially retired from the normal work world, so now I can focus on the things I love to do for fun, and I don't have to do what somebody else wants me to do. So that's kind of a nice change of pace. By the way, when I heard that you guys went to the Computer History Museum, the question that popped up in my mind was, how many things in the museum have you worked on in your career? That's sort of a funny thing to actually look at when you walk around thinking, hey, I used to work on one of those things, and here it is in a museum. Anyway. So let's talk a little bit about the Adventure Radio Protocol. So what's the point of this? What was the original problem that I was trying to solve? There are a couple of things I was thinking about. One is I wanted to figure out a way for field operators to find each other. So today, if you go to the field and want to operate and find somebody else, let's say on the trail at a campsite or just let's say mountain topping peak to peak, it's kind of a random chance where you might find them. There's a few watering holes like 5.2 on 2 meters and so forth, but there's no obvious one place to go and hang out. Also, there's really no standard protocol for emergency calling or even information calling while you're in the backcountry. The closest thing to that is something called the Wilderness Protocol, but we'll talk a little bit about that. But it seems like it'd be nice if there was some sort of way that people could reach out to find each other, whether it's for casual communications like doing let's say a peak to peak on a summit, if you're doing a SOTA, or maybe you actually do have a problem in the backcountry. This is certainly not meant to replace something like an inReach or a satellite phone or something like that. That'll be more reliable. But how can we as hams use our ham radio gear in places where we may not be prepared to do that? Maybe I'm down in a canyon, there's no repeater. What am I going to do? So that's sort of the basic background. Now, if we take a look at some of the options that are out there, you have to really come up with a few elements to the protocol. The protocol is really, it's not so much a technical thing as it is an operational protocol. So what you need first off is a common frequency. So we can agree on a certain frequency to hang out on. So if you do outdoor activities, hiking, biking, off-roading, four-wheeling, whatever, what would be the best frequency for that? We're blessed as ham radio operators to have very large swaths of spectrum. The downside is it's like finding a needle in a haystack. Now, of course, you might be lucky and have your favorite repeater, but maybe you're in a place that doesn't have repeater coverage, or maybe you haven't programmed your repeater, or maybe you just don't know where it is in the area that you're hiking or camping in. So having a common frequency would be useful. The second thing that I think would be useful is having a way to signal what's going on, what kind of traffic is happening on that channel. And one of the downsides of the wilderness protocol is there's no kind of signaling. It's all manual. Um, and so the notion of using subaudible toning for signaling seems like a pretty practical one. We'll talk about that in a moment. And there's really two ways to do this. One is you could do a very simple way where we can just agree on a frequency and a set of tones for certain purposes and just start doing it. I mean, there's nothing to buy, there's nothing to build, there's no code to write. You just start doing it tomorrow. There's nothing that keeps us from doing this right now. So this is not a theoretical thing that maybe someday will exist. It's something we could just start putting into practice today. In fact, in many parts of the country, it's already being adopted, and we'll talk about what the it is in a few minutes here. The second thing, being kind of a DIY nerd myself, I look at something like this and think, man, there must be a way to automate this and maybe take advantage of stations or repeater sites that have some good elevation and might be able to hear calls if someone's calling in, let's say, an emergency. So there must be some way to do some automation to make that more practical than what we do today, which is really uncoordinated. So those are some of the thoughts behind this. So what are some of the current methods that are being used today to do some kind of backwoods signaling? Well, first of all, as I mentioned, there's the wilderness protocol. Many of you have heard of this. It's been around for several decades. And it's very simple. It basically requires the monitoring station to actively listen at the top of the hour 4 times a day for 5 minutes on a set of frequencies. And the frequencies that have been identified are the calling channels on the most popular VHF bands. So 146.52 obviously being number one national calling frequency for 2 meters, 446.0 same thing, 223.5 same thing, 52.525 and 1294.5. So the idea is, okay, it's 7 a.m. I'm going to turn on my radio and listen to 5.2 for 5 minutes. So I, as a receiver looking for a call, would do that. And you, as someone who wants to get a hold of somebody, would have to, first of all, pick one of those 5 frequencies. You're probably going to be on 2 meters, but okay, it's one of 5. And then you're going to pick one of these 4 times during the day to call on the hour. And so what happens if you want to call someone at 9 o'clock? Well, you got to wait until 10, which just seems kind of ridiculous. Now, obviously, you can hang out on 2 meters and you can call and hope somebody's there, but a lot of people don't listen actively to the calling channel, especially during the weekday. And one of the reasons is that, you know, do you want to leave the radio on all the time at the office or at home? Probably not, you know, not unless you're actually listening. So that just doesn't happen. So, you know, what are the odds that this would really be useful? And in my personal estimation, you know, it's better than nothing, but it's not great. It really leaves a lot of room for improvement. The other method that was proposed many, many years ago that's used in some parts of the country, but not very much really anymore, is called a LITS tone, and LITS stands for long tone zero. And the idea is you build a DTMF tone decoder to put on your repeater, and it listens for the DTMF tone zero for a long duration, and typically it's like 10 seconds. So if you hear 10 seconds worth of a zero, something's going on, and that should send out some kind of an alert. The only problem with this really is 2 problems. Number one is that it's really not done very much anymore, almost anywhere. And secondly, there's a lot of radios these days that don't have DTMF pads, which is really irritating. So if you buy your, you know, your brand new ICOM ID52 for $600, the thing doesn't have a DTMF pad on it. Okay, so half the radios out there really can't support DTMF effectively anymore. So that's kind of a less than ideal scenario. So the current methods are really not all that great. So what are we proposing here? So here's the proposal. It all starts with what frequency, because if you don't agree on the frequency, you'll never find anybody. So it all starts with where are you going to be on the band. And rather than 5 different frequencies, and rather than picking one of the national calling frequencies, our Adventure Radio proposal uses a 2 meter simplex frequency that's common across the country, and that's 146.58. Now, if you want to raise an eyebrow and have endless debate with people, let's talk about frequency coordination. That's a rat hole if there ever was one. So as soon as I say this, somebody somewhere is going to say, wait a minute, 146.58 is my Campbell Racy's frequency. We do a net every 3rd Tuesday, and so we can't use that. Well, there's no frequency you can pick that isn't used by somebody at some point during the month for something, but this is not a 24-hour a day, operation. It's not like a repeater. This is really used for more casual communications while people are out in the field, and they're going to be on some frequency. You might as well be on the same frequency. Now, there's some more thought that goes into why 146.58. If you start going through, first of all, which bands would you pick? Probably 2 meters. It's the most universal. Okay, that's pretty obvious. And you want to stick with one of the official simplex frequencies that is consistent with frequency band plans across the country. And not all band plans are the same. If you look across the US, there's many different, slightly different band plans. In fact, one of the challenges is in different coordination councils, some of them use 15 kilohertz frequency spacing, some use 20 kilohertz frequency spacing, et cetera. So, you kind of have to find something that works everywhere. If you look at the end of the simplex bands, like 146.4, for instance, some places that's a repeater frequency, so that's not good. 5.2 is not good because that's the calling frequency. We want to avoid that. So then you start looking at the other kind of frequently used simplex channels. And it turns out that when I started looking into this, 146.58 is already used in parts of the country for outdoors activities. And to my surprise, as I started to promote this idea, I found groups in other parts of the country I didn't even know were already using it. And so weirdly enough, it's not like a totally new idea. People were already doing this. It's also frequently used by 4x4 kind of off-roady hams. I didn't know that either until I started looking into it. So it feels like 146.58 is a reasonable frequency to use. The most important thing in me in terms of frequency selection is that a frequency is picked in a region and that becomes standardized. Now you can debate if 5.8 is the right one or not. Maybe there's a good reason to use something else. For example, in the Phoenix area, there's a very similar thing that they're already doing, but it's on like 144 dot something, an oddball frequency that they picked locally as their outdoor intercom frequency that would be perfect for this application, but it's not this frequency. So, maybe regionally there might be a better one, but it's nice to have a national standard. So we would suggest 146.58 be that frequency. But that's kind of a very important thing to decide, but it's kind of the least interesting part of this whole discussion. Let's see. So then the question is, well, now that we've agreed on the frequency that we would use for this kind of communication, how could we take that simple idea and make it more complicated? Let's figure out a way we can actually add some kind of signaling information so that you can communicate what's going on. So what are the kind of things that you might want to do? And we don't want to overload this idea too much, but if you think about it, there's different scenarios that you might find yourself in if you're operating in the backcountry. So one thing is, obviously, you might have an emergency. There's no guarantee anybody's going to listen, so I wouldn't bank on it, but you want some sort of notion of a higher priority traffic on the channel. You might want to indicate that you're doing some kind of activation, you're looking for calls. So if you're an active SOTA or POTA operator, or you're just out trying to make contacts from a mountaintop or a trail or wherever, it'd be nice to be able to indicate that you're looking for contacts. There might be general reg chew going on. There might even be infrastructure that you can trigger to get some kind of voice playback from a repeater system or something as well. So the question is, well, what would you use for signaling? And we already talked about DTMF. And I personally, having built like a lot of repeater control systems, the first thing I thought of was, well, DTMF, right? It's been done for decades and it works great. The problem is most of the radios you go out to buy today don't have DTMF in it. Now, some of you are going to say, but wait a minute, there's always DTMF memory playback. Well, that's true. So you could can a series of DTMF digits and send it. But have you ever tried to do that on your radio? It's like go into DTMF mode, turn the knob, hit the button, and hopefully it's just not very ergonomically convenient, to put it mildly. The one signaling technique that's universal that every radio has, from the cheapest Chinese disposable radio to the most expensive Japanese radio, amateur or commercial, all radios you can find supports CTCSS or PL tones. So the maximum number of different kinds of information to transmit is only a few, and there's plenty of DTMF tones. So, or excuse me, PL tones. So part of the standard is to define what PL tones are used to indicate what kind of traffic is on the channel. Now, one other reason to actually use PL as your signaling method is that this supports various scenarios. Let me give you an example. Let's say I want to listen to the adventure radio channel, but I don't want to hear, you know, Bob, don't forget the Pringles when you come back to camp. What I want to hear is, hey, I think I've got a problem. So I want to be able to filter out all the, you know, ancillary conversation and just listen to urgent traffic. So I can set my radio to just decode, let's say in this case, 67 hertz as the emergency tone. I don't hear anything. I could leave the radio on 24 hours a day in the house. It's not going to bother anybody until there's an urgent call. So that would be good to know. By the same token, if I'm, let's say, a SOTA operator and I want to make contacts, I might want to put on 88.5, which filters out everything except other people trying to make contacts, let's say for a contest or for, you know, an activation of some sort. But I can filter out, the chit chat about what's happening at the camp or whatnot. So there's various uses for tone signaling like that. You could also, given some infrastructure like a repeater site, you can also build a system where it would respond to tones, not only radio to radio, but radio to infrastructure, like radio to a repeater as a remotely controlled base station. If you do that, you can even do things like automated responses. So for instance, you could use a tone like 77 hertz, and if a repeater hears it, then it could respond with a automated message like, you know, here's a repeater, go to this frequency. Now, this is not useful in a metropolitan area. Let me say that right away. So you don't want to, you know, light up 10 repeaters who are all listening to this and have them all fire back with some information. But if you're out in the boonies and there's not a lot of repeaters and there's maybe a high level repeater, this would be very useful. And in fact, I would want to coordinate that with other repeaters in the area so you don't have a lot of overlap. I've had a number of groups contact me that are very active in supporting search and rescue operations in the mountains, especially in places like Oregon, Idaho, and Montana, where they would like to put in a system like this so that people could chit chat and nothing never bothers them. But if there's an urgent call, they want to have some kind of announcement on the repeater. And so you could use PL decoding to determine what tone and then take appropriate action. So to recap so far, the definition of the protocol, first of all, is let's agree on a channel, 146.58 as the proposed frequency. Secondly, let's agree on a signaling method where specific tones are pre-assigned to do specific actions or for certain kinds of traffic. So that's kind of the core of the idea. So what would you do as a user? Let's say, like, okay, you listen to this whole thing, you go, well, that's kind of an interesting idea. I'm going on a SOTA summit tomorrow. I'm going to use it. Like, what would you do? Well, all you would do to start with is to remember to put your radio on 146.58. And you can just leave it on carrier squelch and just see if other people show up on that frequency. Or you might call your CQ on 5.2, and if you QSY somewhere, QSY to 5.8. Might as well use that. Make the frequency active. You might also choose to encode the tone that indicates you're running SOTA traffic, which is 88.5. Now, you can have your decode on or off. If it were me, I would normally leave my receiver in carrier squelch so I hear everything, but I could have different channels with different PL tones that are essentially set for telling whoever's on the other side what kind of traffic is happening. And then off you go. I mean, that's all there is to it. A friend of mine, KE6MT, Rex, is the SOTA manager for Northern California. And when we first talked about this idea about 2 years ago, he said, oh, that's a great idea. We should do that. And so I know it's becoming more popular in the SOTA community. Up here in the Willamette Valley of Oregon, the guys doing SOTA were already using this frequency totally coincidentally. Nothing to do with it. It was just a complete coincidence. They already picked that frequency. And so you hear a lot of traffic on the weekends with that kind of activity. So it's fun to be able to find the watering hole to know where to hang out. So let's talk a little bit about the more complicated side of this, which, as a guy who likes to build repeaters and repeater control systems, this is where it gets even more interesting for me. And that is, how can I augment my repeater with something like this to provide a infrastructure for the community? Let's say I have a UHF repeater. This is the most obvious example. I get a UHF repeater. I can add to it a 2-meter remote base. A 2-meter remote base is basically a mobile radio that in this case is tuned to the Adventure radio frequency 146.58. And the only thing I would need to make it work is a PL decoder. And you could go buy a commercial PL decoder, off the shelf and cobble it together, and that would be fine because we publish the specification for the frequencies. So you can just get the decoders and hook them up to your repeater however you want and do what you like. So one thing that you might do is you might say, well, okay, the mission that I'm going to execute on my system is I don't want to listen to chit-chat traffic, but what I do want to listen for is that 67 hertz emergency tone. So I'm going to set my remote base to only listen to 67 hertz. And if it hears any traffic on that channel using 67 hertz, it will just pipe that receive audio through to the repeater. So I will hear any urgent calls coming into my repeater. Now, as the repeater administrator, you can decide what to do about that. You can just make that receive only, and if you hear something, then maybe you say, okay, now I'm going to go to my base station and try to call the guy in 2 meters. Or maybe you set this up as a bidirectional remotely controlled base station where you turn the transmitter on 2 meters, and now you can go in on your UHF repeater and out on 2 meters and have a conversation with the guy who's calling with the emergency tone. That's all doable today with a few PL decoders. So that's pretty straightforward. Um, of course, as a designer of this kind of stuff, I've been working on my own design to support this, which is a little bit better than just a few PL decoders. It's actually a scanning decoder, and I'll show you that in a few minutes to make it a little bit easier. This is what the prototype for the controller looks like. And again, like I said, you could, as a user, you can just start doing this today. Or if you want to build your own, you could just get PL decoders and wire them into your repeater however you want, and it'll work fine. I wanted something a little bit more full-featured, so I built a prototype for a scanning PL tone decoder. So what you see here is a picture of the board. This is the first version. Basically, what it does is you take your 2-meter receiver audio and you run it into the radio, or excuse me, into the controller, and then there's another port that goes from this controller to a port on your repeater controller, and this intercepts the COR and the audio coming from the receiver. So nothing goes to the repeater control system unless you program it for a certain tone or set of tones. And so this controller will scan all the PL tones from 67 to 146 hertz. And if it detects any of those tones, then it will take a pre-programmed action, and you can configure what the action is. The action could be, well, ignore the tone, or the action could be to key up the repeater and pass audio, or the action could be to flip a relay, or the action could be to send an ASCII text sequence out a UART to something on the other end of that, which could be, a Raspberry Pi, an Arduino, a computer, or whatever you want, so that you can take whatever action you've programmed into it. So this controller does all of that scanning, decoding, and then creates any of those outputs that you like. It's also providing bidirectional audio and push-to-talk and COR, so that if you take your repeater controller port and run it into this board, it'll then go through this and out to the remote-based radio. So essentially, it provides an intermediate controller between the repeater controller and the remote-based radio to handle the audio and the tone decoding and encoding. So because no project could be complicated enough and there's room on the board, I added a DTMF decoder because why not? So there's no DTMF in the Adventure Radio protocol. But as long as you have this thing, you might as well add a tone decoder, and you can add other features. So if you get any DTMF coming in from the 2-meter remote base, it will generate a ASCII string and squirt it out the UART to whatever is waiting on the other end of that wire to, again, a Raspberry Pi or an Arduino or what have you, to take whatever action based on the sequence of DTMF that comes in. So it really provides room for expansion without you having to build that tone decoding function. So that's the first pass of the controller. It's up and running. There's actually one on my repeater here in in the Willamette Valley area on UHF, and it's working just great. I haven't fanned them out. This is the first one is there on the repeater site. So this is a little bit of a block diagram of how you would hook it up. Typically, you're going to have your repeater plugged into a port on your control system. A simple repeater controller has one port, so you're kind of done if that's what you've got. You really need a multi-port controller where one of those ports can go to a remote base, and then you're good to go. So if you, I'll take a bunch of questions here, but if you have any questions beyond today, you can go to my website and take a look at it. AdventureRadio.info is where I'm open source published the specification for the protocol, such as it is. And it's not like it's complicated. So that's not like a big, big statement, except I want to make sure that we standardize on the tones that are being used. So, you know, you could build whatever you want, but it's nice if it's consistent with other people in other parts of the country or even in the local region about what tones are used. Because again, the last thing you want to do is go like, what frequency should I be on? And, you know, what does the tone mean? You want to pre-program it so no matter where you go, you would have some kind of ability to alert others. We did an episode on the ham radio workbench with Rex KE6MT back in episode 191, so that was a lot of fun. We talked all about SOTA and eventually got around to talking about this project in more detail. K0NR's radio blog did a nice little article on the idea. We have a Discord, ham radio workbench Discord. There's a whole channel dedicated to this topic amongst a bunch of other things. And Josh on Ham Radio Crash Course invited me to come on and talk about it. So I think that's the video we were talking about earlier this evening. So you can go back and watch the video, which is essentially the same slides I'm sharing with you here. So so what's next for this is, of course, you're never happy with the current state of anything, right? You always have to tinker with it. So I'm converting the prototype into a surface mount version of the board, which will probably make it a little bit smaller. And also, the original processor on the board here is an Arduino Nano Every, which is all you need for this application. But it kind of packs pretty much all the flash memory to do all the string processing and all the logic that logical combinations of things you can set. So it chews up a lot of flash, and so I decided to redo it using an ESP32S3, which is significantly larger memory footprint. It's faster, and interestingly enough, it also has Wi-Fi and Bluetooth. And I had absolutely no need for that, but I'm sure we'll come up with something useful. Like one thing you could do with that, for instance, is let's say what you want to do is I'm going to listen on the Adventure radio frequency, and if there's an emergency call, I don't want to do anything on my repeater, but what I want to do is set off a text message to my phone. So I could set up the ESP32 on Wi-Fi to send an SMTP call to send a text message to my phone. So you might have an alert list, you know, here's the 10 people in the club who, when there's an emergency, want to get a text message. And you'll never hear it on the repeater, but you'll get a text message. That's very easy to do because you can just send that SMTP call, or you could have it, you know, send an email, like whatever the thing you want to do. The other last thing that's not really useful for most people, but we're building a new generation of repeater control systems, and this is going to be built into the repeater control system, either built into it or as a plug-in module. That's to be determined, but it'll be fully operable with our multi-port controllers, so that'll be cool. So that's pretty much it. With that, I would be happy to take any questions.
Okay. Any questions here in the room? Oh, yeah, here.
Thank you very much for talking or walking us through this protocol. I understand it. It's simple. And it's efficient. The problem I see is with the FM capture and with setting tone squelch, where you think there's nobody because you filter out radio traffic, but there's people talking without tone or even with a different tone, and you transmit, and then you still kind of you jump into the conversation without the frequency being clear, and that's kind of the only risk I see. Otherwise, it's kind of really nice. Do you have any comments on that?
Oh, for sure. Yeah, you bring up a excellent point, and this is the sort of little detail I didn't really get into in the slides. So, from a practical point of view, let's talk about the scenario. Let's say I'm an active user of the radio, meaning I'm going on a hike. I'm taking my radio. I'm doing a SOTA thing, so I set 88.5 as the SOTA tone. I would never set my radio for PL decode in that case. So if I'm actually actively using the radio, I would always leave the receiver of my radio in carrier squelch, because you never know what's going on that particular channel, right? Unless you want to filter everything out. I mean, the useful thing about filtering everything out radio to radio is if you, let's say, only want to hear an emergency call with the 67 hertz tone, then it makes sense because I don't want to hear anything. And by the way, if I did hear a call with that emergency tone, I would turn off my PL decoder, so I would hear what's on the channel also. So from a practical point of view, what you might do is say, well, there's, maybe there's 5 or 6, 7 different tones that are defined so far. I'm probably only ever going to use 1 or 2, 3 of them. So I'm going to just set the memories in my radio for, let's say, the emergency tone, decode, and just encodes. There's 2 channels. Let's say the SOTA tone, encode only, and encode decode. There's 2 more channels. And then you have it channelized both with PL decode and carrier squelch. So to solve your problem, if you are intending to transmit, if there's a reason to, then you'd want to set your radio so you're in carrier squelch on the receive.
George, were you ever a Motorola service center, or do you have a relative that's very similar name?
My workshop looks like a Motorola service center. That's
Oh,
you're
they
implying.
I used to stop and talk to a fella out in the Evergreen area that his name was very similar to yours.
Well, I lived in Almaden Valley for about 40 years. So I built a lot of repeaters. I built a lot of repeaters with Motorola gear. So yeah, I don't know if that's me, but yeah.
Thank you.
Mhm.
Hi, this is Connie, W6CFI. Not a question, but just a comment that the adventure frequency has also been adopted by hacker conventions and various computer maker type conventions for chit chat and announcements and coordination and so forth. I raise that as a good thing, not as a bad thing for this, because I think the technology is cool, real interesting, but the hard part's going to be adoption.
Mm-hmm.
And so picking a frequency where people are already kind of using it for coordination, and hey, Dave over here needs some help. Can we get somebody to get him some water or something? Is a good thing. So just in case you weren't aware of that, thought you'd like to know.
Thanks, Connie. No, I actually was not aware of that. But I agree with your sentiment exactly. I think that's great. Might as well share that. Now, by the way, in the protocol, the reserved PL tones that would be standardized are the lower half of the tones between 67 and 146 hertz. The PL tones above that, 150 to 230 odd hertz, are left open for whatever purpose you want to use them for. So one thing that could be done, for instance, is let's say there's an event going on, and and people want to use the same frequency. That's great. You might pick one of the tones that's in the upper half, like 167 hertz or something like that. Say, okay, here at DEF CON or whatever it is, we're going to use 167 in the ham radio community, and that's going to be our standard tone, and we'll just use the same frequency, and that'd be great. By the way, the folks who would go to an event like that, I would love to see people like that. One of the reasons I want to do this board, and the reason that I'm making it available, is that I want people to be able to add on to it. Like for me, a lot of times I see a technical gadget and I go, well, that's a really cool gadget. How can I take it and graft it onto something else I want to build? And sometimes it's hard to do. So that's why I wanted to build this thing. So first of all, if you want to build your own from scratch, have at it, right? Here's the standard, please adhere to it. Or if you don't want to do the hardware, here's the core tone decoding hardware. Like the PL scanning is really kind of a pain in the neck. So that's a very specialized little piece of firmware there. That's all done. But having a UART or Wi-Fi or Bluetooth, which the new one will have, now you can hook it up to whatever you want. So you could even say like, well, I don't care about that adventure radio stuff. I just want to be able to press the button on my handy talkie, select a tone and have that flip a relay for some reason. Because I don't have a DTMF pad, and you could do that with the hardware, with the protocol. Anyway, that's a great point. Thank you. Any other questions?
I was searching the room here. How about on Zoom? I haven't seen any questions come up on Zoom. Zoom, go ahead and ask a question there. Nothing. Oh, we got two more in here. Here you go, Alan.
So when you talked about hardware and software, I was thinking, if you have a Raspberry Pi, would it be super difficult to get the audio in and then do some processing, figure out what is the CTSSS tone used, and then do whatever action you want to do over the I2C ports? Because that would kind of make it easier to distribute. There's many Raspberry Pis. You don't have to burn any boards with whatever the custom thing is in there. Have you looked into this as well for adoption?
Yeah.
purposes?
Oh yeah. Yeah. Actually, this is a bit of a like sidebar. When we're designing our new generation repeater control system, we looked at exactly that because, and by the way, that's kind of a Uber version of this. So a repeater controller, the baseband audio processing is much more complex than this because you have to do this plus a bunch of other stuff. And it's traditionally done with purpose-built hardware. So the DTMF decoding is a chip, the PL decoding is a chip, the audio is a bunch of chips. And well, why not just use an ADC and a DAC and a I squared S channel into your Raspberry Pi? That's doable. But there's pros and cons. I know for a lot of people they don't want to hear this level of detail, but doing it on a Raspberry Pi is tricky. It's easier to do with a microcontroller. So the reason is that with a microcontroller, you're not trying to schedule a bunch of stuff. And with a conventional multitasking OS, things may not be happening in real time all the time when you want them to happen. And so you may have blocking kind of behavior. And so to do what you suggest is actually better in a pretty sophisticated microcontroller. Even like a Raspberry Pi Pico would be a better choice because you can control the timing precisely. And you could do you could do exactly this application with an ADC and a DAC and a Raspberry Pi Pico and a whole lot of software. So there's it's like any problem. You push down here to squeeze the hardware down, and it pops up as a bunch of software, and so that's a different kind of complexity. But anyway, you could do that. It's just using a Raspberry Pi with a Linux OS would probably work a lot, but not always. And so I think that's probably not my first choice. But actually, you could do this pretty simply in fixed hardware too. Joe?
Yeah, I've seen a similar thing on a Beagle board, and it was scanning the different PL tones in real time so that it could discriminate. And I guess it was hacked into that new radio that everybody's tearing apart.
Oh, yes.
And you got to put that other board on it to open up all the features. It's like a DC to daylight handy talkie, but it don't work. The more you get toward daylight, that transistor in there ain't made for that.
The tricky thing about using a general purpose processor for this sort of thing is it's fine depending on what your expectations are for performance. So depends on how many tasks it's performing and how many channels of information it's processing and what the response time has to be. So for example, when we're building a repeater controller, our requirement is that anytime there's some sort of tone decoded or action to be taken, the processor has to respond to it within 5 milliseconds. And it has to always be within 5 milliseconds no matter what. It's a little difficult to guarantee that on a general purpose processor, but not on a microcontroller if you're careful with the programming. That's very doable, but it's trickier when you do it on a Linux machine. You know, things that are buffered, like you're doing, you know, audio playback, no big deal. I mean, first of all, the stuff is buffered, so any dropouts are masked by the fact that you've got a buffer, right? So there's a lot of sins that are covered when you're not really operating in real time. But as soon as you want real-time behavior, then you have to have millisecond timing, and it has to be 100% predictable every time, regardless of how much audio signal processing is going on, and that's more difficult. Anyway, that's kind of a big sidebar. Thanks.
Yeah, the BeagleBoard one wasn't doing full voice. It was only doing text. And it had a pretty good thing. They got a network, I guess, down in the Bay Area somewhere that's passing traffic on it like that. And they want to get, like, I live at 2,000 feet up here, and they want me to, you know, put it up. And I said, yeah, well, after I get my tri-bander up for me, then I'll worry about putting something up for you. But every time I get a kid up here to do antenna work, it goes into the high 90s and into the hundreds. So I guess I'm going to have to wait here to get some wire.
By the way, BeagleBone's a great processor. They're not as ubiquitous as the Raspberry Pis, but they're pretty comparable. I've built a lot of projects with the BeagleBones. They're great. Good industrial controllers, actually. All right. Any last questions?
Yes, I've got one. It has to do with your working prototype there. Are you considering finalizing that? And of course, and then do you have any cost predictions or thoughts about availability? Are you going to start manufacturing those, for example, or are you going to have those available? Question mark.
Yeah, the goal is, well, the goal from 2023 was to design the prototype and to finalize the spec on the protocol and publish it. I got the prototype up and running around January of this year, and then I installed the first board on my repeater in March. It's been running fine since then. So I wanted to give it some time to, you know, burn in, right? You know, to make sure there's no failures, and so far there hasn't been, fortunately. So what I'm starting to work on the surface mount version. So no big change to the circuit, just changing all the parts to the SMD version and relaying out the board. I figured out how to have them assembled inexpensively, relatively speaking. This one's hand assembled, that's why it's all through hole. But the next batch will be SMD and automated assembly. I don't know what it's going to cost. I'm hoping it's going to be under $100, but I don't know for sure at this point.
And would you be manufacturing or retail distributing those yourself?
Yeah. They'll be it'll be a Sierra Radio Systems product. So you can go to sierraradio.net, and there's some talk about these sort of things there. I'm also building a companion product which is called a station controller. The station controller, independent of this project, the station controller gives you a Node-RED web UI to control various things around your shack, either in the shack or remotely across the world. So you can turn power on and off and change antennas and all kinds of stuff for your, you know, station automation. And so I figured out this whole automated assembly process for that product. And so along the way, this is getting drafted into that pipeline. So I'm expecting this would probably be available after the first of the year. Well, shortly after, in the first quarter.
Hey, George. One last question from me. Soren, Kilo November 6, Yankee Uniform Hotel.
Yes.
Well, this does probably a great job on the repeater side. I think for someone with an HT in the wild, what I'd rather have most is open up all the CTSSS frequencies, but having a small decoder that I can just clip to my radio that shows me 2 letters of, is this an emergency, POTA, RegQ, that just decodes live the frequency and can just give me a hint, because then I know if I want to switch to the channel where I can just talk to those people, or I can, it literally gives me the hint decoded immediately, and most radios don't do that. So any small inexpensive thing that you can clip on the HT would definitely make adoption much easier.
That's an interesting idea. I never thought of that, because I was thinking that when you're operating in the field, if you really want to be monitoring for something, you would just set your radio, on a channel for each of the different tones you want to monitor, let's say 2 of the tones, and just scan between those 2 channels, and wherever there's traffic, you would hear it because it's decoding. So you wouldn't need anything to plug into the radio. So I'm not sure if that would really be better or not. The one thing that people have asked me for, very similar to what you're suggesting, is could you make a simple one that would just plug into my radio at my base station, so that you have an indicator like a light or a buzzer or something. So if there's a particular tone that gets decoded, maybe I could see the tone on the LCD display, and the bell goes off. But I don't need a bunch of this other audio switching and blah blah. To do that, you can probably get rid of half the parts on this board, and refashion it with some speaker jacks. And although you really can't run speaker audio into it for decoding, because a lot of times that PL tone's rolled off before it gets there. But a lot of radios have those 6-pin DIN connectors in the back. You could just plug in one of those into the decoder and have it as a little desktop thing. So that's basically what you're suggesting, but you want a smaller one that you could clip to your belt. Yeah, that's a very good suggestion. Let me think about that.
All right, Zoom, one last chance. Anybody on there want to get in, and anybody here in the room?
You mentioned that the adoption has happened here and there throughout the country, but it sounds like a small percentage of the country has adopted your adventure frequency. How are you trying to get the word out, and how can others help get the word out?
So let me start with where I'm coming from on my answer. So the secret to a happy life is low expectations. With that in mind, I am not trying to convince the universe to do this, because I can spend the rest of my life trying to get everybody in the world to want to adopt this, and I'll probably be very disappointed by the time that's all over. So I don't even want to go through that. The approach that I'm taking is kind of the opposite, which is figure out how to solve the problem, build a solution for it, and then seek out people who are inclined to want to do this and support them in doing it. And I'm not trying to convince the world. I don't have the time or the energy to try to go to 42 different frequency coordination bodies and get them to all earmark this frequency. It's just hams are difficult to deal with, and it'll take a lifetime to do that. So I'm not even going to try. So my approach is to define what the standard would be, promote it when I can, mostly working with people who either are very active in the like POTA world, and try to work with them to encourage their communities to adopt it without getting the general population to worry about it. Or repeater owners and operators, especially in those areas in the backcountry where this would be really, really useful. And I found quite a few who are interested. So I'm really focusing my energy on the people who already could see the value in it, rather than trying to really evangelize it to people who don't otherwise care. That's not probably the best answer, but it's the truth.
Well, I think a comment I have on that is the word trending. Because when something starts to trend, it picks up interest. So it may just be like a spark that might start a fire at one point, and I hope it does. Maybe that may.
Yeah, I think you're right. I mean, either it will or it won't. Quite frankly, for me personally, if a handful of people adopt this in their region, as far as I'm concerned, mission accomplished. I mean, the idea has been proposed and supported. I'm making the hardware because I know people who want to install it today in their systems, and I want to support their SAR activity or other projects they have going on in their clubs. So I think it's really worthwhile. So that's really my focus. And maybe it'll take off, and maybe people want to do it. That's awesome. Or maybe other people want to make hardware to support it. That's fine with me. But I just, it's really irritated me for a long time as a avid backpacker that there's like no standard place to hang out on the band or way to like signal to somebody, and that's always kind of bugged me. And so this is the way I'm kind of solving my own problem.
All right, George, thank you so much for sharing.
Yeah, thanks very much for having me. Appreciate it.